Mark your attendance.
मैम टाइम लिमिट खत्म हो गया है, 12 बजे तक था।
अटेंडेंस मार्क हो गया है या नहीं हुआ है?
नहीं हुआ मैम।
नहीं हुआ मैम।
टाइम लिमिट एक्सटेंड कर रही हूँ। I will have this time limit 12. Okay. Now mark your attendance. Mark your attendance. Now, the circumferential expansion. The circumferential expansion causes the circumferential expansion. Circumferential expansion causes only you tell me what will happen when the circumferential expansion due to circumferential expansion, what will happen in circular water tank? Before I write here, you guys tell me what will happen when or due to circumferential expansion. What will happen due to circumferential expansion?
मैम क्रैक्स डेवलप हो जाएगा।
क्रैक्स डेवलप होगा। हम लार्ज कैपेसिटी वाटर जब स्टोर करेंगे तो वो डिस्ट्रॉय नहीं होगा ना। रिपीट करो। लार्ज कैपेसिटी वाटर उसमें मतलब अगर लार्ज कैपेसिटी वाटर अगर हम लोग स्टोर करेंगे वाटर टैंक में तो वो डिस्ट्रॉय नहीं करेगा अगर एक्सपेंशन हो करेगा। किसको डिस्ट्रॉय नहीं करेगा मैम? वॉल्स वगैरह को जहाँ पे फ्लेक्सिबल हम लोग अगर सरकमफ्रेंस बनाएंगे तो ओके। तो वाटर सॉरी जो वॉल है वॉल विल नॉट डैमेज और क्रैक। Not damage and destroy. Not damage and destroy. Okay. And what will happen? And what will happen? Think again. What will happen if there is some circumferential expansion exists? Then what will happen? Tell me, what will happen due to circumferential expansion? Think again. क्रिटिकल एज नहीं आएगा। क्रिटिकल एज नहीं आएगा। And first tell me what will happen when we apply pressure or we apply push or pull in a material. What will happen when we apply a push?
मैम मटेरियल में डिफॉर्मेशन हो जाएगा।
Due to push, it will try to contract, right?
Yes, ma'am.
Or due to pull, it will try to expand, right?
Yes, ma'am.
And
Yes, ma'am.
due
Yes, ma'am.
to this expansion, a tension will develop. I am right or wrong?
Yes, ma'am.
Due
Right,
to
ma'am.
expansion, a tension will develop, right? In normal scenario,
Yes, ma'am.
right? But in case of circular water tank or circular design structure, when a circumferential expansion exists, then in that case, a tension will develop due to expansion, and this type of tension is called hoop tension. Hoop tension. Means the hoop tension, also known as circumferential tension, due to expansion of circumferential wall, there will be a tension will be developed
In that case, and that tension is known as hoop tension. And this hoop tension in the wall will also increase linearly, right? Due to circumferential expansion, hoop tension is generated in the wall, and when hoop tension is generated in the wall, it will also increase linearly. Linearly means top to the base of the wall. Means top to the base of the wall. Matlab, at top it is minimum and at base it is maximum. Circumferential expansion causes hoop tension in the wall, which will also increase linearly from top to the base of the wall. Is it clear?
Yes, ma'am.
Then what is this hoop or circumferential stress? And why before what? Why? First, what is hoop or circumferential stress or tension? Hoop or circumferential pressure subjected to internal water pressure. Due to internal water pressure, wall of the circular water tank will try to expand, and due to this expansion, a hoop or circumferential stress will be generated in the wall of the circular water tank. Is sigma C is equivalent to PD divided by 2T, where P is your internal water pressure. Right? Sigma C is equivalent to PD by 2T. And D is where D is dia of the tank. and T is thickness of the wall. Thickness of the wall. Means I will try to draw a circular wall. It will look like this. Right? This is your circular wall. Circular wall. This is your circular wall of your tank, where hoop tension is acting like that in this direction T, and this is your wall thickness small t, and again this is your the direction of hook or axial tension. Hook or axial tension. T is your hook or axial tension. This is your thickness of the wall, and the direction of your hook tension or axial tension is in this way, right? From simple stress strain formula, we also know that stress is equivalent to stress equals to what? सिंपल स्ट्रेस स्ट्रेन फॉर्मूला से हम लोग को पता है स्ट्रेस इज इक्विवेलेंट टू क्या होता है
Force by area.
force by area, right? Force by area, and here force is intention, therefore instead of F we write here T, which is your hook or axial tension, and area is small t into first I draw once again a circular wall. Okay, this is your circular wall, and this is your wall thickness. Hoop will be act like this or in this direction. And this is your thickness of the wall, right? We consider here height of the wall up to 1 meter, up to 1 meter. Here we consider height of the wall up to 1 meter. In that case, from simple stress and strain formula, sigma is equivalent to T by area, right? Here T is your hoop or axial tension, and what is the area, and area becomes for up to 1 meter height of the wall, up to 1 meter height of the wall, T into 1. Up to 1 meter height of the circular water tank, we also write here sigma is equivalent to T by area, and area is equivalent to T into 1. Right? For up to only 1 meter height. Is it clear?
Yes, sir.
And then we have two types of stress formula. First one is sigma is equivalent to PD by 2T. Say it's equation 1. And second one is sigma is equivalent to T divided by small t into 1. Say it is equation 2. By equating equation 1 and 2, then what we get in terms of T? Then what we get in terms of T?
T is equal to PD by 2.
Right, T is equal to, 1 second, first I write here. Then tell me what we get in terms of T.
PD by 2.
PD by 2. Right? Means the value of your tension, is T into D by 2. Right? And T is equivalent to PD by 2, and we also know that at the base hoop tension also increase linearly. Then at the base the value of hoop tension T is equivalent to, at the base hoop tension is equivalent to what?
मैम गामा डब्ल्यू इंटू एच होगा.
Right. D is constant. D is your dia of the circular water tank, which is constant. P, pressure changes, na? Pressure changes from top to the bottom. It means at the base, I also told you, hoop tension increases linearly. Means at the top, it is 0 and at the base, it is maximum.
Yes,
And
ma'am.
at base, the value of pressure P is equivalent to gamma WH, right? In that case,
Yes.
at the base, we also write that maximum hoop tension at the base, T max, is equivalent to PD by 2T, 2 means gamma WH into D by 2. This is your T max at base. You all understood up to this?
Yes,
Maximum.
ma'am.
Right. Then the section of wall should be designed for the hoop tension. Then it means the section of wall should also be designed for the hoop tension. And due to flexible joint we provide at the between the base and wall, there is no case of bending moment. There is no case of bending moment. Why? Movement is generated at fixed condition, but here we provide a flexible joint where movement is allowed. In that case, there is no case of bending moment. Right? You all understood or not?
एक बार रिपीट कर दीजिए ना.
We in circular water tank, when we provide or we construct a flexible base, when we construct a flexible base means we provide a movement joint, either it will be sliding or contraction or expansion. If we provide a flexible joint between wall and base, there is no case of bending moment. It is clear or not?
Yes,
Yes,
ma'am.
ma'am. हो गया. Yes, ma'am.
Clear है? If
Yes, ma'am.
joint is fixed, then bending moment will generated in that case. But when load is acting, then as a reaction, the wall will expand or contract. That's why no moment will be generated in this case. Clear?
Yes, ma'am. Yes, ma'am.
Okay. There is no case of bending moment due to flexible joint, and there is no bending moment means no fixity or rigidity, means no fixity or rigidity between wall and base slab, base slab, right? And also when the hoop when the pressure decreases from base to top, hoop tension also decreases. When the pressure decreases, pressure means water pressure decreases from base to top, means from base to top, then the hoop tension also decreases. Just vice versa, when the hoop tension increases linearly, means from top it's 0 and from base it is maximum. Therefore, steel may be reduced at the top. Therefore, we will deduct steel reinforcement steel at the top. Why? Because of less pressure. Why? Because of less pressure at the top. And also we reduced or decreased the wall thickness at the top, but only and only in case of a very large capacity of tank. But in generally, we avoid to reduce the thickness of the wall. Am I clear?
Yes, ma'am.
Yes, ma'am.
Hoop tension or hoop steel, due to hoop tension, we provide steel reinforcement in the wall. Therefore, this type of reinforcement is also known as hoop steel, which is also known as main steel. Sorry, main steel. Oh, main steel, which is also known as main steel, and we provide main steel in the form of horizontal rings. We provide this hoop steel or main steel in the form of horizontal ring, means ऐसे, right? hoop steel means a main steel, or we provide hoop steel along the circumference of the tank. That's why we provide a main steel or hoop steel in the form of horizontal rings. Means, okay, horizontal rings means this is again your one wall of your circular water tank. And we provide reinforcement like this. Here wall is discontinuous. That's why it looks like a horizontal bar. But when the wall is circular, then the steel bar we provide here is look like a horizontal ring. Means this is your wall. Base slab and again it will look like this. Means in terms of a horizontal ring, we provide a hoop steel or main steel reinforcement. And in reality or in 3D view, it looks like this. But I draw here in 2D, or wall is discontinuous. That's why it looks like a horizontal bar. But in actual or in 3D, it looks like a horizontal. Is it clear?
Yes, ma'am.
Vertical steel and hoop steel is provided as horizontal ring or horizontal ring is also known as main steel, but vertical steel we also provide a vertical steel, and this vertical steel is provided as a distribution steel, and we place generally a distribution steel in inner layer. Means vertical steel is called distribution steel, and it is placed in inner layer.